So we are talking about tree banks. We are talking about tree banks. We have seen that uh, CFG, though it is very effective, but still there were three problems with CFG, and those three problems were solved with tree banks. So what are tree banks? Tree banks are collection of manually annotated sentences or corpora. So it will have a sentence and a corresponding parse tree. Immediately the question comes, does it contain all the sentences in the world or all the languages in the world? No, it contains only few which are manually annotated. But what we can do is we can use a machine learning model, we can use a supervised learning model, and with the existing tree bank data, we can develop a model to find the parse tree for the sentences which are not present in the tree bank. That is what we are going to do. So if you see the differences between tree bank and CFG, so CFG is a rule-based approach. That means we have rule-based approach. Here it is data-driven approach. We are driven by the data, not by the rules. Here it is, because it is rules, there will be many number of rules, and we have also seen that we cannot represent all the rules, but here we don't have any rules, we have the data. And this is used for NLP more in the tree banks. And CFG used for linguistic and formal syntax. This is rigid, this is flexible, and with the tree bank, we can develop a more other tree banks with existing data. Now, there are two types of tree banks. One is called phrase structure tree banks, and another one dependency tree bank. Phrase structure tree banks and dependency tree banks. In the real world, already there are famous examples for this. For phrase structure tree bank, there is a tree bank developed by a university which is called as Penn Tree Bank, and here it is UD, Universal Dependencies Tree Bank. What I'm saying, these two are examples. Examples. Now, phrase structure tree bank will have the POS phrases. Remember, phrase structure tree bank is also called constituency. Constituency tree bank. For example, you have a sentence, Jesse loves apple. So this can be represented as start symbol, then verb phrase that is sorry, sentence, then noun phrase. What is the noun phrase? Just see. Then verb phrase, loves, then another noun phrase, apple. So everywhere, the each word is represented by its POS tag. So this is another example of the phrase structure trees. So where we represented everything with its POS tag, parts of speech tag. So here each word is individual, and we are what we are doing is we are just representing them with their parts of speech tag. That's what we are doing. In dependency tree bank, what we do is we explore the relation or the dependencies between the words. First, we'll see which was the head word. So we divided the given words into, we'll choose one word as a head word and the remaining words as dependent words, dependents. So, for example, if you take the sentence, Jersey loves apples, which is the head? Generally, remember, rule of thumb, predicate will be the root. What is predicate? Verb. In the given sentence, predicate is the verb. That will be the root. That will be the head word. So, John uh, eats apple. So here it is the predicate. So we call that as a root word. So you will have a directed arrow towards the root. Remember, head word will have only one incoming arrow from the root, and the remaining will be originated from this. Now, from who eats apples? John. What he will eat? So these arcs they represent. Sometimes they may be labeled arcs, something like subject, and this is object, noun phrase. This is also noun phrase. This is known as labeled dependency path. So phrase structure parsing, which is this is more effective because it captures the relation or dependencies among the words. And if these arcs, if they don't intersect each other, we call that type of dependency parsing grammar as projective grammar. What is projective grammar? Where the dependency arcs will not intersect each other. That is known as projective grammar. If it is projective tree, we can back propagate and find the corresponding grammar if it is projective. But if it is non-projective, that means they intersect each other, we cannot get the CFG from the tree. So this is about tree bank and phrase structure tree bank and dependency tree bank.